Summary: conservation of energy, is expressed for a cycle and change of total energy are them of total energy are then written for a control mass, kinetic and potential energy, can be changed through the work of force acting on the control mass. And they are part of the total energy. The internal energy and enthalpy are introduced as substance properties with the specific heat as derivatives of this with temperature. Properties variations for limited case are presented for incompressible state of a substance such as liquids and solid, and for highly compressible state as an ideal gas. The specific heat for solids and liquids change little with temperature, whereas the specific heat for a gas can be changed substantially with temperature. The energy equation is also shown in rate form to cover equation is also shown in rate form. You should have learned a number of skills and acquired ability from the studying this chapter. You should first recognize the component of total energy stored in a control mass. Stored in a control mass write the energy equation for a single uniform control mass. Energy equation for a single uniform control mass. Find the properties U and H for a given state table in appendix B. Locate a state in table with an entry such as P, E, and H. A state in the table with an entry such as and find change in U and H for liquid or solid states. Using table A3, A4 or F2. And F3. Find change in the U and H for ideal gas states. Using table A5. A5 and F4. Find change in U and H for ideal gas state. Using table A7, A8, or F5 and F6. Recognize that forms for CP in table X6 are approximation to what is shown in figure 5 and table A7, A8, F5, F6. Formulate the conservation of mass. Energy for a control mass that goes through a process. Involving work and heat transfer. Formulate the conservation of mass and energy for more complex control mass, different masses. There are different masses and different states. States and use the energy equation in a rate form. And the last one is now the difference between the general laws as the conservation of mass, conservation of energy, and the specific between the general laws as the conservation of mass, conservation of energy, and the specific law that describes a device behavior or process. behavior or process.